all of the questions on the front already have common denominators, so you won't have to create common denominators. But what I want to remind you of, when you already have a common denominator, you don't change it when you actually add or subtract fractions. So if I just look at this very first question, both of them have a 3a in the bottom. When you add them together, that denominator does not change. The denominator should just stay 3a. And then what you do to actually add it is you add the top. So the numerator, so 8 and 1 is 9. And then once you're there, if you can simplify, you are allowed to do that. If not, then just leave it alone. So can I simplify 9 over 3a in any way? Yeah. It's just be 3 over a. And then the homework is not going to ask you guys to do any restrictions today, but restriction there we would say we don't want a to be 0. Okay, now if you've got a subtraction question, I don't really worry about this too much with the addition, but if you have a subtraction question, you have to remember that you have to subtract all the parts on whatever you are subtracting. So if there's a couple terms, then don't forget to think about that as like distributing the subtraction. All right, so I'd have 4x minus 3 on the bottom. Okay, so I'd have 5x, right? But then it would be minus a negative 7x. So 5x minus a negative 7x is actually 5x plus 7x. So if I combine those like terms, I'd have 12x. And then for my numbers, I have negative 1 minus a positive 8. So just negative 1 minus 8. So that would be negative 9. Now, before I write that as my answer, I can't just cross x's off, right? But I want to see if I can factor anything in any way to see if something matches. So on the top of that fraction, do 12x and 9 have anything in common? 3. Okay, so if I divided both of those terms by 3, bless you, left over 12 divided by 3 would be 4. We'd still have the x with it. That negative 9 divided by 3 would be negative 3. And then what ends up happening here, I do have a product on the top. So I'm multiplying 3 times that 4x minus 3. Because that matches what I have on the bottom, you are allowed to cross this out. So then my answer here is actually just 3. So as you do these problems, make sure you have a common denominator before you add or subtract, but then see if you can factor to see if anything might cancel. And sometimes it does, sometimes it doesn't. It just kind of depends on the question. Okay, so let's see here. This one's going to be subtraction. Again, I do have a common denominator, but if you're subtracting, just make sure you think about subtracting all the parts of whatever follows that subtraction sign. So like here, if I do x squared minus x squared, then that will just go away. All right, I'd have a 7x, and there's no plain term with an x in this other fraction, so nothing to combine that with. So then it would just be minus a negative 35. So it's actually going to be plus 35. And then maybe I just do this real quick to see if anything cancels. Can anybody tell me how I could factor x squared plus x minus 20? So multiply to get negative 20, add to get positive 1. What? Yes. Okay. X plus 5, x minus 4. And can I factor the 7x plus 35 in any way? 7. Okay. And so we'd have the x plus 5. Now, I got a product on the top, product on the bottom. And in this example, one of the factors on the top, the x plus 5, does match one on the bottom. It doesn't always happen, but if it does, you can cross it out. And so my answer here would be 7 over x minus 4. And then we can't go any further than that. It's not too bad. These problems are not terrible. You just got to be real careful. I put a lot more subtraction on here just to make sure you guys get used to that, because that can help solve these problems better if you do more practice. So if I've got, let's see here, I've just got an x squared on the top of this first fraction, so there's nothing I'm combining that with. And I'm going to do negative 6x minus another x, so it'd be minus 7x, so negative 6 minus 1. And then for the 12, I've got minus a negative, so that would actually be plus 12 on the top. Our common denominator there was x squared minus x minus 12. And then I would just see if we can, don't just like cross the 12s out or the x squareds. People are tempted to do that sometimes. It has to be a product before you can do that. And I have adding and subtracting in both the top and the bottom of this. So we're going to try and factor it. Can you think of two numbers multiply, give you 12, add to get you -7 for the top of the fraction? Yes, -4, -3. And it doesn't matter the order you put them in, they're being multiplied. What about multiply to get -12, add to get -1 for the bottom of the fraction? Go ahead. -4 and +3. So that multiplies to give you -12, but adds to get you the -1. So the 4 has to be negative. And then what ends up happening here, there is an x minus 4 on the top, x minus 4 on the bottom. So you can cross those out. And I'm just going to be lazy here. My actual answer would be the x minus 3 over x plus 3. Nothing else cancels there because there's one's a plus and one's a minus, so they don't match. All right, I got one more, and then we'll start working on some that we have to maybe create a common denominator for. So common denominator between these two fractions is x plus 3. And again, I put a lot of subtraction on here to practice this. So distribute the subtraction symbol. So on the top there, I'd have x squared, and then I'd have 12x here minus 2x here. So 12x minus 2x would give me 10x. And then I don't have any plain number on that first fraction, so I don't need to worry about combining that there. But you have minus a -12, so that's actually, or sorry, -21. So it's going to turn into positive 21. And then our common denominator on the bottom there was the x plus 3. Can you guys think of factors of 21 that add up to 10? What do you think? Yeah. Yes. Thank you, sir. +7, +3. Okay, now that x plus 3 is on the bottom there, so those match. So this actually just totally cancels the fraction out. So my answer would just end up being x plus 7. And no more fraction. Is anybody having a question? Okay. Now, all these guys on the front had a common denominator, so see if you remember this maybe from earlier in your math career. If I want to add or subtract fractions, you do have to have a common denominator, but sometimes we'll have a problem that doesn't have a common denominator. So if I just want to practice this with numbers, so if I want to add 1/2 and 1/3 by hand, what would you do there to be able to add those fractions together? Like, how would I need to manipulate those fractions so I could do that, since I don't have a common denominator the way it's presented there? Like, what would you do to each of the fractions? Okay, so what number would you use? Okay, so what would you do to the first fraction? Good. Okay. Now, I'm not picking on you in any way, but I'm really multiplying both of these fractions by 1. You do 3 on the top and the bottom. That way you're not changing the value of the expression. I can always multiply by 1, but people always want to say, like, multiply by 3, multiply by 2. You are really multiplying by 1. You're just manipulating it for your purposes to make the common denominator. So 3 top and bottom, 2 top and bottom. And what you'll get here then, this would be 3/6, which would be the same as a half, right? It's basically like unsimplifying a fraction so you can add them together here. And then 2 times 1 is 2, 2 times 3 is 6. There we've got our common denominator. 2/6 would reduce back to 1/3, so just keep that in mind. Now, once you have that, don't change the denominator when you add or subtract. So I should keep a 6 on the bottom there, and then 3 plus 2 on the top would be where we would get 5. What if I wanted to subtract 3/10 from 4/5? How would I have to manipulate that problem to be able to subtract there? So we don't have a common denominator. Yeah. Yes. Okay, do I need to do anything to the other fraction? No. So sometimes you might have to multiply both fractions. Sometimes you might only have to multiply one. In this case, you get 8/10. And then this was already in tenths, so we didn't have to manipulate that second fraction to get a common denominator here. If you subtract this, you get 5/10, and then you are allowed to reduce, just like we've been reducing up above if we had factors in common here. So this would reduce to 1/2 as our answer. Is anybody having a question about finding a common denominator between numbers? Because we're going to do it on the back with variables. Okay. Now, these are always tempting for people to try to just add or subtract something to manipulate their denominator. And you cannot add or subtract. You have to multiply. So if I have this first fraction, I have 2 over x minus 4, and then I'm trying to add to that 3 over x plus 2. I can't just like add 6 to the top and bottom of this and manipulate it that way. It has to be with multiplication. So I look at it as, what am I missing here? So this one has an x minus 4, this one does not. So I have to do this with multiplication. I would need to put x plus 4 top and bottom. That's really multiplying by 1, but I'm trying to make a common denominator. Oh my gosh. Forgive me. X minus 4. I don't know why I put a plus. X minus 4. I'm trying to make it match the other one. I accidentally put a plus. That should be x minus 4. I'm sorry. All right. And then to make the other one match, this has an x plus 2. This does not. So we would need x plus 2 top and bottom here. Now, please don't FOIL the denominator. Just leave the denominator in factored form. We're going to simplify the top and see where we can go from there. So in this problem, when I get my common denominator on the top, all I would have to do would just be a little distributive property. So 2 times x would be 2x, 2 times 2 would be 4. And that would be over our common denominator, x plus 2, x minus 4. All right, now, remember I screwed this up. I started to write a plus. This should be x minus 4. So a little distributive property here. This would be 3x minus 12. And then x plus 2, x minus 4 is our common denominator. You don't have to write those in a particular order as long as the factors are the same. And then what I would do here, don't try to factor here. What you actually want to do, just add straight across the top, leave the bottom alone. That's your common denominator. So just see if you can combine like terms. So 2x and 3x would give you 5x. 4 minus 12 would give you negative 8. And then if you can factor that, go ahead and see if it cancels anything in the bottom. In this example, 5x and negative 8 don't have anything in common, so that's just going to be my answer. Nothing else is going to factor out or cancel or anything, and don't FOIL the bottom of those fractions. Only work on the top and then see if you can cancel anything out, but just go ahead and leave the bottom in factored form. Okay, now the question right next to this. This is the one that everybody always messes up because they see an x plus 9 here and they see an x here, and they don't write this on your paper. They will literally just add 9 to the top and add 9 to the bottom. You can't do that. It has to be multiplication. So if this has an x plus 9, then to make it a common denominator, to make it match, I'm going to need to multiply top and bottom of that second fraction by x plus 9. This fraction has just a plain x by itself, so to create that common denominator, I'm going to need to multiply the top and bottom of that first fraction by x. You can't just add and subtract things in here. It has to be multiplication. So if they don't match, you're just going to multiply the top and bottom by whatever you see in the bottom of the other fraction. All right, now for this guy here, just on the top, just 3 times x, so just 3x. And then we'd have, just leave this in factored form. Don't multiply this out. So x times x plus 9. That's our common denominator. Over here, we'd need to do a little distributive property. So I've got 3x plus 27. And then again, my common denominator here was x times x plus 9. So at that point, I haven't actually added. I was just creating the common denominator. Once you have that common denominator, then go ahead, just add or subtract depending on what you're doing for the question, just straight across the top. So 3x and 3x, don't multiply them, that'll give you 6x. And then I just have 27. On the bottom, I have x times x plus 9. Now, I just want to check if the numerator can be factored in any way. Maybe I would recommend, try to do that, and it might cancel something, it might not. It's going to depend on the question, but make sure you at least check. So 6 and 27 are both divisible by 3. And so if I took a 3 out in front, you would have 2x plus 9 left. Now, that does not actually cancel anything in the bottom, but I'm just making sure, I'm just double checking to see if anything would go away. It doesn't here, so we're just going to leave it in factored form. Nothing ends up canceling in that situation. Is anybody having a question? Well, okay, now, like, if you were right here and you're like, nothing's going to cancel, you could leave it alone, but just leave the bottom in factored form for sure. But if you want to leave it, if you look at this and you're like, nothing's going to cancel, that's fine. I was just checking. Yeah. Yeah, don't FOIL the bottom out, though. That's just wasting time. I know you can multiply, I know you can FOIL, so just leave it in factored form. It's easier to see the restrictions that way if a question asks you for that anyway. So just work with the top and leave the bottom in factored form. And if you can factor the top, you might just check. That is a good example. That didn't cancel anything. I would take either one of those answers. Okay, now this one. If one of the denominators can be factored, try to do that really quick before you get a common denominator, because I really don't want to multiply the top and bottom of this by x squared minus 3x plus 2 if I don't have to. So let's just see real quick what the factored form of that would be before I try to create my common denominator. Can you guys think of two numbers would multiply to give you 2, add to give you -3 for that quadratic? Yes. Okay, so the factored form of that is x minus 2 times x minus 1. Now, if you guys notice, I already have an x minus 2 here. So I don't need to multiply the top and bottom of that first fraction by that quadratic. All I am missing is the x minus 1. So I'm going to just multiply here, top and bottom by x minus 1, and then our denominators will match. So if you want to factor first, a lot of the times one or maybe two of the factors, depending on the question, you might already have them and not know it. So I only need an x minus 1 in the top and bottom of that first fraction to make these match. I don't have to manipulate the second fraction in any way. Okay, now this one's a little tricky because I have to FOIL this. So if I do that real quick, I'm just going to write it out in one step, but x squared, or x times x give you x squared. In the middle, you're going to get positive 3x, and then you'll get negative 1x on those two middle terms. So 3x minus x would end up being 2x, and then the plain number negative 1 times 3 is negative 3. And again, I'm just going to, don't FOIL the bottom, just leave that in factored form. And I'm subtracting what I have next to this here. So when I subtract, you have to subtract the 6x and the negative 7. So think about that as like distributing a negative. And so I just have an x squared, so I'm going to leave that alone. Now, 2x minus 6x. So 2 minus 6 would be negative 4x. And then for your plain numbers, you got negative 3, but then it's minus a negative 7. So negative 3 minus a negative turns into negative 3 plus 7. So that would actually be 4. And then just leave that bottom in factored form. And before I write that as my answer, just try and see if you can think of two numbers multiplied to give you positive 4, add to give you negative 4? You can. What two numbers multiply to give you positive 4 but add to give you negative 4? Yes. This is actually, that top of that is called a perfect square trinomial. The two factors are both the same, x minus 2 times x minus 2. Multiplies to give you positive 4, adds to give you negative 4 in the middle. Now, this is a good example because I have an x minus 2 in the bottom. Now, I have two x minus 2's in the top, but I only have 1 in the bottom. So to cancel anything, it's just 1 for 1. So this one factor in the top cancels this one factor in the bottom, and then the leftover, which I'm just going to be a little lazy here and just kind of circle this, x minus 2, I'd still have 1 left on the top, and an x minus 1 on the bottom. That would be my answer. Is anybody having a question? Okay, the one right next to this is kind of weird, but this is the same kind of a recommendation I would give to you. if you can factor the denominator in any way, or on either of these fractions, try to do that because you might have more in common than you think to actually just initially look at the problem. So, can I factor 5x plus 10? Like, do they have, it's not a quadratic, but can I factor 5x plus 10 in any way? Do 5x and 10 have anything in common? No one wants to talk. Ryan, you tell me, you're shaking your head. 5. Okay, what would you have left over? All right, good deal. Now, what about, I have a 5 on the top here, so I'm not factoring anything. What about 12x and 24? They have anything in common? 12. Okay, what would be left over? X plus 2. Okay, now, do you guys see? I have an x plus 2 already in both of these denominators. So they already have that in common. So basically what I need to make it match is I have to deal with the 5 and the 12. Does anybody know what you would multiply the first fraction by to make that happen? 12, yeah. The smallest thing that 12 and 5 both go into is what you get when you multiply 12 and 5, which is 60. So I would need a 12, just a plain number, top and bottom here, and then you would need a 5, top and bottom here. Now, here's what I'm going to have you guys do. If you have to just multiply by a number, like the top of this, just 12 times 4 is 48. Now, on the bottom, I'm going to do 12 times 5, but I'm not going to distribute that. I'm going to leave the bottom in factored form, but I am going to multiply 12 times 5. So 12 times 5 is 60. And then we'd have the x plus 2. Now, the other fraction, just on the top, 5 times 5 is 25. And I'm going to do the same thing here. 5 times 12 would be 60. And then we have the x plus 2. So I've got my common denominator there. And then on this problem, I'm not factoring or dealing with anything else. I'm literally just subtracting 25 from 48. So across the top, if you do 48 minus 25, you get 23. And then on the bottom, we'd have 60 times x plus 2. Now, 23 and 60, you're not reducing that. 23 is a prime number. It doesn't have anything other than 1 that'll divide into it. So, like if I had a 24 on the top, we could maybe reduce something, but I don't have that in this question, so we'd just leave that as our answer and just go ahead and leave the bottom in factored form. Okay, now I have one more, and this problem is kind of hard. So, on the top, I just have a 2x, and then on the bottom, I have a difference of squares. So x squared minus 9, multiply to get negative 9, add to get 0. We're going to have an x plus 3 and an x minus 3 in no particular order. Okay, on the other fraction, I got a 5 on the top. The bottom, I've got x squared plus x minus 6. So let me think about this for a second. Multiply to get negative 6, add to get 1. Okay, has to be plus 3 minus 2, right? Stop me if that's wrong. Okay. Now, if you look at these two fractions, this guy has an x plus 3, and so does this. So those already match. So we only want to put in what we're missing. This first fraction has an x minus 3. This one does not. So what I would do to create a common denominator here, x minus 3, top and bottom. This fraction, the second one, has an x minus 2. This one does not. So again, to create a common denominator here, we're going to need to get that multiplied into our denominator, top and bottom. So I'm going to multiply top and bottom by x minus 2. Okay, now on this first fraction, I'm just going to do a little distributive property. So 2 times x would be, or sorry, 2x times x is 2x squared. And then 2x times that negative 2 is going to be negative 4x. The other fraction here, I'm going to add in between, I'm distributing a 5. So that would be 5x, and then 5 times that negative 3 is going to be negative 15. This is just the numerator. Combine my like terms here. I'm going to get 2x squared plus x minus 15. And then I'm kind of like making a face and being like, Miss Grody, you're mean, because I have to do the Berry method for this. Okay, so that's just a numerator. I'm going to factor the top real quick. All right, so I've got a number in front of my x squared, so I'm going to do this little Berry method here real quick. just take that first term, which is 2x squared, drop the squared, and put that at the beginning of both of your factors. This will not be the answer, but this is the fastest way I have ever learned to do this. Okay, you're going to multiply a times c, ax squared plus bx plus c. So 2 times negative 15, first and last. This will be negative 30. And add to get the coefficient in the middle, which is just 1x, so just 1. So can you think of two numbers when you multiply them, you'd get negative 30, and then you'd add them, you'd get positive 1. Negative 5 and positive 6. Okay, one or both of these will not be the real factor, because that would not FOIL to give me what I have above there. To get the real factor, if you don't have it, you're just looking to see if the two terms have anything in common. So in this question, 2x and 5 were good, but 2x and 6, this is not the real factor. So the real factored form here should be 2x minus 5, and then both of those terms are divisible by 2. So the real factor would be x plus 3. Okay, now that whole thing is just the numerator of this fraction. So let me come back up here and I'll put that up here. So I have 2x minus 5 times x plus 3. The denominator, our common denominator in any order, was x minus 2, x plus 3, and x minus 3. And when I did factor that quadratic, one of the factors on the top does match one of the factors on the bottom, so we can just go ahead and cross these x plus 3's out. So my final answer here, you'd have 2x minus 5, and then on the bottom, don't FOIL, just leave it in factored form, x minus 2 times x minus 3. Nothing else cancels there. I know this is really a lot of heavy algebra with factoring and things like that just in general in this unit, but that's what's going on.